In this video, we're going to practice solving a kinematic problem using the formulas in the toolbox. We know that in kinematics, there are 5 key variables. They are the displacement, delta d, the initial velocity, vi, the final velocity, vf, acceleration, a, and the time, delta t. Usually we'll be given some of these values and asked to solve for the others. And this toolbox contains all the formulas that relate these variables. And our job is to figure out which variables we have and then choose the right formula to use. Okay, now let's use a race car as an example. Imagine a race car slows down from 20 meters per second to a complete stop over a distance of 50 meters. And what variables do we get from this? Or what are the given variables from this? First, we know the car's initial speed or the initial velocity, vi, is 20 meters per second. While the velocity is actually a vector, it includes both the magnitude and direction. But we are now dealing with a one-dimensional problem, so we can just assume that the car is moving forward. So if we add the direction of the velocity, so it's forward. Okay, then we can add this little arrow on top, but the direction won't affect our calculations. Okay, so what else do we have? Because the car stops completely, then we know that the final velocity, Vf, is 0 meter per second. And also because it travels a distance of 50 meters during this process, and we know that the displacement, delta d, is 50 meters, and the direction is also forward. And that's all the information we have right now. We know the displacement, the initial velocity, the final velocity, and what variables are we solving for? For part A, we need to find the acceleration. Okay, we need to find the acceleration A. And for part B, we are asked to find the time, delta t. Now let's find the correct formula from the toolbox. To solve for the acceleration, we need an equation that includes the acceleration and only the variables we already know. Okay, for the first formula, it doesn't contain acceleration at all, so we can't use it. The second formula contains both acceleration and time, but we don't know the time yet, so we cannot solve for two unknowns with a single equation, so we cannot use the second one. Then how about the third one? The third one also contains both acceleration and time, so we cannot use it either. The fourth one contains the acceleration, and all the rest are the known variables, right? We know the Vf, we know Vi, and we know delta D, right? So this is perfect formula. So for part A, we're going to use this formula, Vf squared equals to Vi squared plus 2a delta D. Let's rearrange this formula to solve for A. We can subtract Vi squared from both sides. It becomes Vf squared minus Vi squared equals to 2a delta D. Then we isolate A as A equals to Vf squared minus Vi squared divided by 2 delta D. Now let's substitute the values. We have A equals 2, Vf is 0 meter per second squared minus Vi is 20 meter per second squared divided by 2 times delta D is 50 meter. So A equals 2, 0 minus 20 squared is 400 divided by 2 times 50 is 100. So it equals to minus 4 meter per second squared. Wait a second, why did we get a negative number here? Don't be panicked, there's nothing wrong here. Okay, remember acceleration is a vector, which means it has both the magnitude and direction. A negative sign here simply indicates that the direction of the acceleration is opposite to the car's direction of motion. Since we've defined the car's initial velocity is forward, okay, it's positive direction, then a negative acceleration means the car's acceleration is backwards, right? Or the car is deaccelerating or slowing down. Okay, that makes perfect sense because the car slows down to a complete stop, right? Okay, now let's move on to the second part of the question, finding the time delta t. Since we've already calculated the acceleration, the time is now the only unknown variable. And this means we can use any formula as long as it contains delta t. Okay, so let's just use this second one, which looks straightforward. Let's write it down here first. Vf equals to Vi plus A delta t. Let's rearrange this equation to solve for delta t. So we can subtract Vi on both sides. Vf minus Vi equals to A times delta t. Then delta t equals to Vf minus Vi divided by the acceleration. Now let's plug in the values. It equals to Vf is 0 meter per second minus Vi is 20 meter per second divided by the acceleration, which is minus 4 meter per second squared. Remember to be careful with the signs. We get a negative value for the acceleration from the previous calculation, so we have to use exactly what we got, and don't miss this negative sign. So we get delta t equals to minus 20 meter per second divided by minus 4 meter per second squared. So the time equals to 5 seconds. Okay, so the acceleration is minus 4 meter per second squared, and the time delta t is 5 seconds. Okay, I hope this video was helpful in explaining how to solve kinematic problems. And if you liked it, please consider giving it a thumbs up and subscribing for more physics tutorial videos.